All right. Hello, geometry kids. I'm missing you in class. Still a big hole in the middle of the classroom, so someday soon you'll be back. But today's Wednesday, April 21st, and we reviewed on central angles with arcs. So I gave a little pop quiz, if you will. So please pause the video, answer these 4 questions, and then hit play, and I will work through them. So pause now. Okay, so I hope you took the time to work these on your own, but I'm going to find the measure of the missing arcs or angles. So what I like to do is take markers, colored pencils, highlighters, whatever I have. There's a lot going on, especially number 2, and it gets a little confusing as to what I'm looking for. So I like to outline what I need. So for number 1, I'm looking for this arc. This arc is formed by an angle. So from the endpoints of my arc, I can draw an angle. This is a central angle, so the measure of the central angle is the same measure as the arc. So this arc is 130 degrees. So C is my answer. Okay, looking at number 2, I'm looking for an angle measure. So the angle measure that I'm looking for here. So my angle forms an arc. We call this the intercepted arc. The intercepted arc, which is an arc inside of an angle. They're going to be the same. So my arc is 95 degrees, so this angle is 95 degrees. All right, looking at my 3rd example, I am looking for an arc. Here is my arc. This arc is formed by an angle. They're going to be the same. So my angle is 125, so my arc is 125. And then one more. I'm looking for an arc again. This arc is formed by an angle. Here's my angle. They're going to be the same measure. My arc is 120 degrees. My angle is 120 degrees. All right, so I hope you took the quiz with me. Hope you did well. If you're struggling, remember you can always message me and I can work some problems with you, whatever you need. So far we've talked about 2 types of angles in a circle. We can have a central angle where the vertex is at the center of a circle. And we've discussed inscribed angles where the vertex is on the circle, like on the side. So we learned yesterday that the central angle is the same as the measure of the arc. Today we're going to, we're going to look at inscribed angles. So I've got a picture here. Now, bad news, I printed this, so I can't like manipulate the things, but I do have some patty paper. All right, so I have a central angle. So angle BAC is a central angle. So angle BAC is a central angle. All right, and then I have an inscribed angle, which is angle BDC. So angle BDC is an inscribed angle. All right. Both of these angles, it was done on purpose, intercept the same arc. So both of these intercept arc BC. So let's start with this arc measure. Let's say that this arc is 62 degrees. So based on what I know about central angles, the central angle and its intercepted arc have the same degree. So this angle is also 62 degrees. But what about my intercepted arc? So I'm going to use my patty paper here, and I'm going to copy down my angle DBC. And now I can move it. So if I overlap my inscribed angle to my central angle, you will notice that my inscribed angle is not 62 degrees. So my inscribed angle, when I move it to my central angle, and I know my central angle is 62, my inscribed angle is not. My inscribed angle is actually half 62 degrees. Because if I come back down here and I make another inscribed angle, it actually fills in the entire central angle. So inscribed angles form arcs, but they're not the same measurement as the arc. A central angle is the same. The inscribed is going to be half. So here is my formula, my definition of an inscribed angle. And I'm going to draw a picture with my circle. Circles are hard to draw, so when you're taking notes, you can print off the notes that I have blank and then fill things in. Or if you have something that's round that you can trace, or, I mean, your circle doesn't have to be the most perfectly round circle, it'll be okay. So I have an inscribed angle and I have an arc. So the measure of the angle is half the arc. So the measure of angle ABC is equal to 1/2 the measure of arc AC. So if I know this arc measure, I can half it to get the angle. But what if I have the angle? Instead of halving the arc to get the angle, if I have the angle, then I can double the angle to get the arc. So 2 times the measure of angle ABC is equal to the measure of arc AC. So I like to talk about both of these formulas. You can either half the arc to get the angle, or you can double the angle to get the arc. Do either one. All right, so I've got a few examples here. My first one, that number is super small, hard to see. This number is 96 degrees. All right, so this picture, I have a central angle, I have an inscribed angle. I have parts of inscribed angles over here, but they don't connect all the way on. I do not have a diameter, so I can't necessarily cut my circle in half to find missing pieces. So I've got to use what I've got. So my angle that is 96 degrees, I'm going to highlight it. Then I'm going to highlight the arc that it forms. So since angle ADB is a central angle, the measure of arc AB is 96 degrees. Okay. And then I'm going to look for the measure of angle ACB. Here is its intercepted arc. I already have the measurement for it. So the measure of this intercepted, or this angle that forms this intercepted arc 96 is exactly half. So half of 96 is going to be equal to 48. So my inscribed angle is half the arc, 48 degrees. All right, I've got 4 problems down here. I did encourage the class to write down problems 1 and 3 because they're kind of multi-steppers and helpful to have information. So for problem number 1, I like to highlight what I'm looking for. I'm looking for an angle. So here's the angle that I'm missing. Inside that angle, I have an intercepted arc, and here's my intercepted arc. I don't know the measure of this intercepted arc, so I'm going to have to look elsewhere to help me find out some other measurements. So I do have this arc KF, which is 106. KF is formed by this angle, but that's not going to help me with my triangle. But if you notice, this point is the center, and this line is a diameter. Please look for diameters. Number 2 does not have a diameter because it doesn't go through that point. Number 1 does. So that means that these 2 arcs, the pink and the yellow, are going to add up to 180. So this is going to be 180 less 106. Ooh, let me check my mental math. I think that's 74. Where's my calculator? I got too much stuff on my desk. Yep, that's 74. So now I know the measure of the arc, and then my angle is going to be exactly half 74, which is 37 degrees. So highlight what you're looking for, and then look elsewhere if you need to find something with that intercepted arc. All right, with my second question, I'm looking for an angle EFD. Here is the intercepted arc, which I don't know the measure of. Now there's two approaches to this problem. I'm going to start with my 168, or I could start with the 56. I'm going to look at the 168 first. So 168 is this arc here, and it is formed by this angle, which means I should be able to find this angle by taking the 168 and dividing it by 2. This angle is 84. I now have a triangle where I know 2 of the angles, and I need to find the third one. All angles in a triangle are going to add up to 180. So this x plus the 56 plus the 84 is going to be equal to 180. 84 and 56 is 140. So my x is 40 degrees. I'd like to show you a different way to solve the same problem. If I had not started with the 168, but I had started with the 56, this angle is 56 degrees. So this arc is exactly twice that, which would be 112 degrees. Then, knowing the pink and the blue arc, the yellow completes the circle. So this, we can say x plus 168 plus the 112 is equal to 180. 168 plus 112 is 280. Oh, so sorry, not 180. Ooh, that would be bad. It'd be negative. The whole circle adds up to 360. All right, so x plus 280 equals 360. And 360 minus 280 is 80. So this arc is 80 degrees, and then the angle that's inscribed from it is exactly half of 40. So it doesn't really matter how you solve it, as long as you solve it. All right, looking at number 3, this is a good multi-stepper. I'm looking for an arc. Here's my arc. This arc does not come from one inscribed angle. I can attach Q to M, but not M to Q. Or I can attach K to L, but not L to Q. So you could not put in new lines because it might affect the 70 degree or the 65 degree angle. So I'm going to take what I have in the picture, see if I can figure something out. So I'm going to start with this 70 degree angle. This inscribed angle is going to form this entire arc here. This entire arc is going to be twice the 70, which will be 140. So if the entire pink arc is 140, and I already know that this part of it is 70, then K to L is 70 degrees. I don't have a diameter, so I can't use my 180 degrees because I need more than 180 because the chord is below the diameter. But let's use my angle that's 65 degrees. This angle will form this arc, which includes that 70 and then the piece that I'm missing. So twice 65 is going to be 130. So if the entire blue arc is 130, and this part is already 70, then this missing arc that I'm looking for is 60 degrees. So the thing about circles, you got to figure out what you have, what do you need, and then how can you bridge the gap to get there. All right, and then problem number 4. I have an inscribed angle. Here is its intercepted arc, and I don't know what the measurement is, and I don't have a diameter, but I do have two other arcs. So the 85 arc and the 105 arc plus this pink arc are going to add up to the entire circle of 360. So x plus the 85 plus the 105 is equal to 360. So that should be a plus. So x plus 190 is equal to 360. So that missing arc is 70. Hold on. Minus 190 is 170 degrees. All right. So this arc is 170 degrees. So my angle is exactly half of 170 degrees, which is 85 degrees. All right. Two additional topics to talk about. Quadrilaterals and circles. Quadrilaterals have super special properties in dealing with circles. They do fancy things. So if we have a quadrilateral that is inscribed in the circle, meaning that's inside and all the vertices touch, and or we have a circle that is circumscribed about the quadrilateral, which means the circle goes around and touches all the vertex, then the opposite angles of an inscribed quadrilateral are supplementary. And let me show you why that works. So let's say I'm looking at these two angles on the left and the right. I'm going to prove to you that they add up to 180 degrees without knowing what they are. Would you love a proof? So angle 1, highlighted, forms this arc. I don't know what the arc measurement is, but it's twice angle 1. All right, angle 2 is going to form this arc. I don't know what it is, but the arc will be twice angle 2. So if I put x's with these, I could call this arc 2x, this arc 1x. I probably should switch my 1 and 2. But altogether they're going to add up to 360. So the arcs sum to 360 degrees. The angles are going to sum to exactly half that because I have to half the arcs. So the angles sum to 180 degrees, which is kind of the bigger deal. So if this green arc, let's say, was 200 degrees, and then this pink arc was 160 degrees, that would give me my full 360. This pink angle 2 is half of 160, which is 80. And then my angle 1 green is half the 200, which will be 100, and then they add up to 180. So you'll use these properties in some of the homework questions where you have quadrilaterals with some variables in them. All right, and then we're looking at congruent angles in a circle. So in this picture, I have two inscribed angles. I labeled them 1 and 2. So here's angle 1. And its intercepted arc. And here is angle 2 with its intercepted arc. So these are different angles. They're in different positions. They have different vertices. However, they intercept the same arc. So we're looking at inscribed. Did I spell that out? Inscribed angles forming the same intercepted arc. They're going to be congruent angles. So let's say that this arc, let's say this angle is 25 degrees. That means this intercepted arc AB is twice that, 50. All right, if this arc is 50, then this intercepted arc is exactly half that, 25 degrees. So if you're intercepting the same arc with inscribed angles, you'll know that the angles can be equal to each other. All right, so I have 2 pages for homework tonight, so make sure you get both of those printed and completed. If you need help with printing, let me know. and I will see you guys soon. Have a great day.